Hello, good morning, guys. I'm recording this lesson on panel data regression. I'll be providing you the our MD file for this. Okay, so let's start. So panel data regression, when you say panel, you're referring to a longitudinal data set. As distinguished from cross-sectional, where you're looking only at a snapshot, one particular point in time of data about different units, and a time series where you have one unit taken across several time, years or months or weeks. A panel data, on the other hand, is a combination of a cross-sectional and a time series data. So as in your notes, it says here that it's a data set where there are repeated observations on the same units or individuals, can be households, firms, countries, or any entities that remain stable over time. So you have several individuals, several units with data across several different time. So you have repeated observations that create a potentially large panel data set. So if you have n units and t time periods, then you have n times t observations. The advantage of this is we have a large sample size, and that will be great for estimation. The disadvantage is that there's a possible dependence of observations. Okay, and then the modeling can be modeling the potential dependence creates different models. Okay, there are two types according to whether it's balanced or not balanced. When you say balanced, every unit, person, country, company is observed every year. So for example, if you're observing ASEAN, okay, for let's say 5 years, each of the units are represented for those 5 years. An unbalanced is one in which at least one member is not observed at every period. For example, let's say ASEAN data from 2010 to 2018. Then in 2010, maybe you have only 4 countries. And then in 2011, it became 5 countries, which means the other one was not present in 2010. That's called an unbalanced data. You also have long format and wide format. Look at long as vertical, which means the data is tabulated in a vertical form, and wide as horizontal. So if in the long format, if one row holds one observation per time. Okay. So on the other hand, in wide format, isang row kompleto na yon. Okay, usually pag nagpa-panel data, minsan pwedeng we work on both long and wide format. Okay, so I have given here some additional reference. You might, I encourage you to look at this reference to learn more about fundamentals of panel data. So the data that we're going to use is the wage data. Okay, I already uploaded this in our Canvas. And so kindly, I already uploaded this in the R file here. Okay, so let me just view this. Let's take a look at the data. Okay, so we have, this is experience, number of weeks. These are, I think, location. So, and then you have here education. And then you have here experience squared, this one, which is just your experience raised to the second power. And this is a panel data because you can see this ID here refers to person number 1. And this time here refers to the first year, second year, third year, fourth year, fifth year, sixth year, seventh year. So your T here is 7, and then your N here is, how many do we have? Okay, we have to, later we're going to get the summary, and we'll see how many how many different, the levels of your ID. But if I go down, see if we can see it here. There, 595. 595 is our N, number of units, number of individuals. Okay, so 595 times T, so that's 7. So that will give you, that's 4165. I'm not sure. 4165 entries all in all. Okay, 4165, that's 7 times 595. Okay, so kindly check that. All right, let's take a look at our, this will be our dependent variable, the log of wage. And we'd like to see how the log of wage is related to the number of years of experience, and then the number of years, the number of weeks worked in a particular year, and then education, and then experience squared. So we'll have 4 regressors. Now let's look at the nature of the regressors. Experience, if you notice, varies across time. So this is year 1, year 2, year 3, year 4, year 5, year 6, year 7. Okay, you notice that it changes by one year, of course, because every additional year would mean an additional year of experience. For weeks, this varies across time. This means in year 1, individual 1 worked for 32 weeks. In the next year, he or she worked for 43 weeks, and then 40 weeks, etc. And then individual 2, okay, experience 30 years, then 31, 32, 33, okay, and then weeks worked last year, year 1, 34, etc. So you notice that they differ in terms of experience. Observation 1 is different in terms of experience with individual 2. And also they differ in terms of weeks worked per year, okay? Now, education, you see that for individual 1, it's 9 years. So education is time invariant. Okay, so for year 1, for individual 1, he had 9 years of experience. And on the second year, he still had 9 years of experience, which means 9 years of education, sorry, which means that education was not, there was no addition as far as education is concerned. So this is what we call a time invariant variable or data. Now, of course, ID is time invariant also, because the ID does not change across time. So in year 1, it's still person number 1. In year 2, it's still person number 2, etc. So this is for person number 1. This is for person number 2. Okay. All right. So let's continue our discussion. All right. I also, let's take the summary. Okay, for ID, very correct. We have 595 different units or 595 different individuals. Okay, this is quite big. So we might have some challenges with the plotting later on. But usually, if you're working on panel data, usually it's not really this big as far as the number of units is concerned. For example, if you're working on ASEAN, then that will be, for example, ASEAN 5, then that will be only five units, and then depending on the years. Here, there are 595 different individuals or different units, and taken across 7 years. All right. Okay, so, and then I'm going to attach that data, our data wage, so that it will be easy for me to look at the different variables of that data set. Okay, is this a panel data? Yes, this is a panel data. What type is this? This seems to be a balanced data. It's balanced, okay, because there are seven units, 7 individuals, 7 years. Sorry, 595. Sorry, if I have 595 different units and 7 individuals. So if you multiply that, let's see, 595 times 7. Okay, 4165. So correct, 4165 complete. So this is a balanced panel data because all the data about each individual is complete per time period. 4165, 4165. Okay. Then, is this, yes. What are the variables contained? We already explained that. Okay, there are several variables here, but we're only going to work on the experience, the number of weeks worked, the level of education, and experience squared. Experience squared. And then of course, this is what makes it a panel data. The ID here, the individual, and the time component. Okay, so we're going to do first OLS and then panel data. Okay, so as I mentioned a while ago, we're going to focus on the log of wage. Okay, this is time variant and varies between individuals. When you say time variant, if you take a look, for example, at individual 1, notice that the log wage, the average log wage of this individual varies across time. Okay, so for year 1, it was 5.56. For year 2, 5.72, etc. Okay. Then experience refers to the years of experience, and this is time variant. When you say time variant, it varies over time. However, the variation is only is discrete. It's 1 year. So 3 years of experience on the first year, and then 4 years, etc. It's a constant increase of 1. Then we have weeks worked per year, which is also time variant, and it varies between individuals. And as I mentioned a while ago, education, which is years of experience, this varies between individuals, but it is time invariant. Let's take a look at that. Education for individual 1, okay. So 9 years across the 7-year period. It simply means that the number of years of education did not increase. So perhaps we were measuring here the either primary, secondary, and even collegiate level. So if this individual seems like this individual has already finished that, so no more increase in this. So that's what we mean by time invariant. For invariant means does not change over time. Okay. Of course, experience changes over time. Weeks also is time variant. Education is not, and experience squared is also time variant. Okay. ID, of course, is time invariant. It does not change over time. All right. So then that's our education. All right, now, in order to facilitate our panel regression, we're going to create 2 objects. Let's call it Y, and that's the, it has only a lone content, log wage. Now take note, we have already attached wage. This means that R knows that this L wage comes from the wage data set. And also we're going to create X, and it will constitute experience squared, weeks, and education. R also understands that this is coming from your wage data set. Now let's summarize this and get the structure. Okay, sorry, I haven't created this. Okay. So now that I have created X and Y, let's summarize this and get the structure of X and Y. Okay, so this is the summary of Y, which is our log wage. You have the minimum and the maximum and the first quartile, etc. So the same for your experience squared, weeks, and education. And then the structure of this, okay, so this is just a list. This is just a list. So we will have to change this later on as factor when we do our regression. Okay, so take note, our y and x are just lists. Okay, so our y, our log wage is a list, and so is our x, which consists of experience squared, weeks, and education. Okay, now both the data set is only as I mentioned, so we'll be converting this later on into factor when we do regression. Now in panel data, we have to convert our data into a panel data series so that we can work on panel data regression. The way to go about it is so we have to make use of the PLM package. It's already uploaded here. This is PLM. This is the main package used for panel data regression. Okay, so we're going to create a new object called panel wage. This is the panel conversion of your wage data set into a panel data. So the function is pdata.frame. Okay, this is what the code, this is the function that we're going to use. And this is from the PLM package. So wage, we're using the wage function, the wage data set. And then we have to define the index. We have to define the unit and the time. So in our data, our unit is named ID and our time is named T. So we have to identify that using the index function. It's concatenating ID for your unit and T for your time. So we have to put first your unit. So we're identifying the cross-sectional dimension first, and then the time dimension. So it's ID and T. Of course, if your cross-sectional data, if your unit was named differently, you have to change this. So for example, it's country, then you have to write here country, and then if the time was in years, so you have to put here. Depending on the name of the variable. Since it's ID here and T here, then we're going to use that for converting our wage data set into a panel data. Okay, so then let's take a look. Let's run this now. Okay, now we take a look at the structure of P wage. Okay, you see P.frame. It's already a panel data. Okay, so it's no longer a list, it's a panel data already. So we can now make use of this object, of this data set, P wage, for our panel data regression. Okay, now let's try to plot first. Okay, we might have some difficulties with this one. I think I chose a very a data set that has a big number of units. It will be good for you to practice and look for a data set where the units are fewer, so that the plotting will be more apparent. So here we're going to co-plot y with t, okay, with t given as ID, and the type is line, and then the data is P wage. Let's see if this will run. Okay, that's a problem we have. Okay, let me run it in the console. Oops, sorry, I picked the wrong. It's not the P wage. It's this one. Okay, it's a problem here, guys, because we have so many. Even if I zoom this, okay, what are these? These are the different individuals. So there are 595 of them. Okay, so it's quite difficult to see this. Okay, so let's go to the other plot. This time it's plotting we're plotting the time, and since there are only 7 years, so this is workable. So co-plot, okay, co-plot, Control C. It's also too big. Oh, sorry. Margins are too large. So let me, okay. Okay, let's dispense with this first. I was expecting this because we have, these are 595 individuals. Okay, I'm sorry. We have 595 individuals here. So, okay, so let's go to the regression first. Let's now go to regression. So our first regression will be to do a pooled OLS, ordinary least squares. So what happens here? This is multiple regression where the units and the time are disregarded. So it's just like a multiple regression where we do not consider the differences across the groups, the ID, or the time. Okay, so we're going to call it OLS. Okay, and it's just the linear model between Y, which is your log wage, and your X, which consists of your 4 variables. And we're using the panel wage data. Okay, so let's run this. Okay, so we now have here, okay, the residuals are here. Okay, and then you have the usual regression outputs. Okay, so you have experience, and then you have X here, which means that these variables were placed into this object X. So object X, and then experience, okay, and all of these are significant. So for example, how do we interpret this? How would we interpret this 4.486? So that's point 0.04, okay, 0.0446. How do we interpret that? Since our dependent variable is logged, okay, Y is log wage. So we therefore interpret this as for every 1 unit, or experience is number of years, for every 1 year change in experience. Okay, so why don't I write that here? So interpretation of XEXP. For every 1 year, let me write this, that's B1 is equal to 0.00468. Okay, so for every 1 year increase in experience, in work experience, there is a corresponding, so do you remember this, guys? How do you interpret this? There is a corresponding, okay, okay, since nakalog si experience, hindi nakalog si LN wage, hindi nakalog si experience, we will have to multiply LN wage with 100. So this becomes 0.468, and then you have to attach the percent, okay? 0.468% increase in the wage of okay, increase in the wage, okay, then ceteris paribus. Okay, so that's how we interpret this coefficient. All right. Now, what we did here was just to do the OLS, the basic multiple regression. Another way to do it is we can use the panel data regression function in PLM. So let's call it pooling. Okay, and then we're going to use now PLM. This is panel linear model. When you use this, you have to identify the model, the type of model that you're using. So here you have Y, regression X, still the same data, but our model will be equal to pooling. Okay, notice the use of PLM instead of LM. And this is, as I said, coming from the PLM package. All right, then let's run this. Okay, then we have the same output as above. Okay, we have the same. So the pooling method is actually the same as the OLS method. So notice our regressors are just the X, those in the X, experience squared, weeks, and education. So it totally disregarded the effect of your ID, the individual, and the time. Okay, so that's the first model. Okay, then later on we'll do statistical test and see if this is okay compared to the other models. Okay, so we can use here Stargazer. Let's just show that. Okay, so these are our dependent variable Y is our log wage. So these are your independent variables. 4165 number of observations, R squared 0.284. Okay. F-stat 411, degree of freedom 4, because we have 4 regressors, and the degree of freedom 2 is 4160. You got this from N, which is 4165 minus K, which is 4 minus 1. So it's 4160. All right, then let's go now to, all right. Now it would be best to plot, guys. Here I'm actually plotting the means of your Y and your T. Okay. However, I'm not sure if this will work because we have a huge individual unit. Let's see. Let me run it here in the console. Let's run it here. Is there a plus? Is the data here incomplete? Plot means Y T main is equal to. It's okay. Okay, there's an error here. There. should work. I wonder why it's getting error. Okay, this is the plot, guys. So you notice that this is across time. Okay, across time. So this is your 95% confidence interval. So you notice that across time, the average is increasing. So there, we can conclude that there's differences across time. There's heterogeneity across time. Okay, the LN wage varies across time for year 1, year 2, year 3, year 4, year 5, year 6, year 7. Okay, so what does this tell us? It tells us that maybe time could be a good predictor for log wage. So which means that maybe we can use time as a predictor for log wage. And then for this one, okay, let's also copy this, Control C. Let's see if each individual units has their own contribution to the log wage, which means that unit 1 has a different contribution to log wage up to unit 595. They have unique contributions to log wage. So let's see, oops, this one. This is now the problem because we have 595 different individuals. So it's very difficult to see, but we can see here that okay, the dots there are the averages. So with 595, you expect that they'll be really different from each other, and they have different contributions to explaining the log wage. But we'll have a statistical test for this. Okay, so this is our problem because our data is quite huge as far as the number of units is concerned. Okay, but I'm going to maybe send another data set where there are much less units, so that you can see really the plot. Okay, so let's go here now. Okay, that's the first regression that we did was to just ignore the heterogeneity of time and the heterogeneity across individuals. So we're saying that no, individual 1, ID number 1, ID number 2, they don't have any difference as far as explaining your log wage is concerned. Also time, it doesn't have any no difference at all of its explanatory power over the dependent variable log wage. Okay, now what we're going to do is we'll do what we call the Lsdb. That's our second model now. That's the least squares dummy variable. So what will happen here? We're still going to use OLS. However, we're going to introduce the effect of time and the effect of individuals. So we're going to introduce ID and time as dummy variables. So they now become part of the regression model. All right, so in the first part, so we have both time and ID as dummy variables. So you know what dummy variables mean, right, guys? We're using them as regressors also to try to explain the log of wage. Okay. Now take note, there are 595 different units. So this will mean that there will be 594 dummy variables. Okay. And then unit number 1 will not appear in your regression model, but our explanation, our interpretation of the dummy variables will be benchmarked against the reference variable, which in this case is unit number 1. Also with time. For time, there are 7 years, so we'll have 6 dummy variables for time. So let's run this. Okay. Okay, we're now creating another object, dummy variable 2A, and we're using this LM. Our LN wage regressed on your 4 regressors for explanatory variables. And then we're going to add plus the factor time, okay? And factor ID. Notice that we're converting time as a factor, because in the initial data, it was a list. However, we actually have already converted it into no. This is just to make it a panel data. So we're converting time and ID as factors. So let's run this. All right. So let's take a look at the output. Okay, so you have here the 4 regressors, okay, and the intercept, because we were regressing Y on X, the LN weights on the 4 regressors, plus you have the dummy variable T and ID. Now, as I mentioned, guys, the time, you have now 6 dummy variables here. 6 dummy variables. Because we have 7 years. So year number 1 will be dropped from this list, but everything will be interpreted in terms of the first year. But notice they are not significant, right? They're not significant. Now, if you take a look at this, okay, there was a change as far as experience is concerned in its as it affects log wage. The first one was this one, 0.00468. Now this time it's around 0.10. Okay, e to the negative 1, that's around 0.1127. So you notice that you could see now the increase in the effect of experience as far as log wage is concerned when we include the other dummy variables. Now for the dummy variables for the units, we will have 594. So that's quite many. That's quite many. 594 all in all. It was not shown here. Okay, 594 dummy variables, because there are 595 observations, and then you decrease it by 1, so you have 594. And all of these are to be, all of these dummy variables for the ID are to be interpreted in terms of your benchmark variable, which is ID1. So for instance, ID2 or individual number 2 has a lower, okay, lower effect on log wage as compared to individual number 1. Okay, so the change in log wage for individual number 2 is less by this amount, 2.28, okay, because of the minus, etc. Now you have a lot here. Okay, maybe it would not be a good way to model, because there are far too many dummy variables. So what we're going to do now is just, okay, the model above allows us to look at the differences between the years and the units, but it does not contribute much to the interest of seeing the effect of the independent variables. We're really interested to know the contribution of the independent variables on log wage. Okay. Now let's see if we just include not the ID as a factor, but only time. Because as I said, ID has 594 dummy variables, and it's really impossible, if not practically impossible, to look at this in relation to ID number 1. So here, we're also going to do LM. This is also Lsdb, list squares dummy variable, but we're only looking at T as a factor. Okay, so let's, so what will happen here is that we will have the output of your X4 regressors plus T as a dummy variable, and there are only 6. There are only 6 dummy variables. Okay, let's run this. All right, so the effect of your intercept. okay, and then your 4 regressors, and then your factors. Okay, so here you can see that these are significant. Okay, it means that this is to be interpreted as in relation to factor number 1. So this means that as far as year 2 is concerned, it has a greater effect on the log of wage, okay, by 6.998 to the second times 10 to the second power as compared to 10 to the negative 2 as compared to year number 1. Okay. All right. So this is now your Lsdb, but we only consider T as a factor, time as a factor. So as I mentioned a while ago, this is our code for that. We're including factor, the time factor as a regressor, and then we were expecting only 6 dummy variables because there are 7 years. 7 minus 1, that's 6, and the results here are all expressed in reference to time number 1. Okay. Now here, how about with ID as a factor? We have actually done this. So what will happen now is that we're now creating an LM, a linear model, adding the factor ID without the time. Okay. Then this will be the same as the one above, but this time no time component, no time dummy variables. All right. So there, we remove the time variable here. Okay. Again, as I mentioned a while ago, this is quite difficult to interpret with so many units. This type of regression will only be good if you have really manageable number of individuals or units. But 595 will be quite big. Okay, so so far we have done just OLS. Okay, all our models here are LM. Okay, except for this one, this is actually PLM, but it's the same as OLS. Okay. All right. So we have done the first one. What we have done is just use the regressors. Just ignore the components of your panel data. We're ignoring the effect of the units and ignore the effect of time. So we're treating them as just homogeneous. We're not looking at them in the light of the fact that they are heterogeneous. Heterogeneous for the ID and heterogeneity of your time. Here, in the second part, what we did was to include the effect of factor and time as regressors. So we're just introducing this as dummy variables. Okay, we're not actually looking at this as a panel data, since we're just using the LM function for this. I'll explain that in a while. And then here, okay, we only use T as a factor, and then here ID as a factor. Okay, if we're analyzing this as a panel data PLM, then there will be something that will happen, something different. You'll have a different output because there will be some assumptions that will be observed in a panel data. Okay, now we go to fixed effects. Okay, what's fixed effects? Okay, in fixed effects, we explore the relationship between the predictor and the outcome variables within a certain within an entity. Each entity has its own individual characteristics that may or may not explain. Okay, may not explain the influence of predictor variables. Just okay. For example, we're taking a look at being a female or a male. Okay, so we can, in the fixed effects, we can take a look at the differences between let's say the response of a male or the response of a female. if that was our unit. If our unit, for example, were let's say a particular country, so we have several countries, and then our, let's say our dependent variable was GDP. Okay, we can, in fixed effect, we can see the different effects of the country as far as the GDP is concerned. Okay, so when using fixed effects, we assume that something within the individual may impact or bias the predictor or outcome variable, and we need to control. We need to control for this. Okay, this is the rationale behind the assumption of the correlation between the entity's error term and the predictor variables. Later on, we'll see this when we do the Hausman test for testing between fixed effects and random effects. Okay, let's now go to the model. This is model number 3A. You have fixed effects, okay, but we're only looking at time effects only. So in other words, we're not going to look at the individual effects of ID, just time. Okay. However, when we do panel linear regression model, since we're looking at time as and its contribution to the changes in log range, what will happen is that any time invariant variable will be removed from this model. Okay, so take note of that. Since we're looking at time as the effect of time, the different times, we have time 1, time 2, time 3, time 4 on the dependent variable, which is the log range. What will happen is that all the regressors, all the variables that do not vary with time, they will be removed. Okay, since in this model they will have no use kasi hindi naman sila nagbabago. Eh ang tinitingnan natin yung pagbabago, yung effect ng change of time dun sa dependent variable natin. So going back to our data, okay, take a look at ed. Sinabi ko na to kanina, education, di ba? Education is time invariant. So we expect that education will be dropped from this fixed effects model. Kasi wala namang change sa ano to eh. It does not change over time. Eh ang tinitingnan natin yung effect ng changes over time. Okay? So experience, what will happen? Okay? It will still be there kasi nagbabago naman siya over time. Weeks will still be there kasi it changes over time. And so will experience squared B since it changes over time. So what will only enter the model are those variables that changes over time. Kasi nga gusto natin makita, as I mentioned a while ago, ano ba yung effect ng time dun sa dependent variable natin. Okay? All right, so let's run this. So let's call it fixed effect with time. And then take note, we're using PLM now. Kasi kanina, di ba late, a while ago guys, we also regress this. Sinama natin si factor. Pero pag linear model lang kasi, pag OLS lang, hindi siya magtatanggal ng mga time invariant variables. Isasama pa rin ni OLS lahat. Ito guys, pag PLM na, pag panel data na, okay, so we're going to use this function PLM, and take note, pag PLM laging i-identify natin yung model. So yung model niyan is equal to within. So it's fixed effect within the time. So tinitingnan natin yung differences ng contribution ng time 1, time 2, time 3, time 4 in explaining your dependent variable log range. Okay, so let's run this. Let's run everything. Okay. Take note guys. Ano na lang nangyari dun sa regressors natin? Andiyan pa sa experience kasi time variant yan. Experience squared, andiyan pa rin. Okay? Si weeks, andiyan pa rin because these are all time variant. Nagbabago sila over time. Kaya, pwede nila ma-explain si log range. However, guys, ano nangyari? Si education nawala, tinanggal. No? That we explained a while ago. Now, ito yung difference, guys, ng yung fixed effect at saka yung OLS. Yung kanina, yung LM natin, LMY on X plus factor T. No? Ito yun. Okay. This one. Ito. This one. LMY on X plus the factor T. Pero ito linear model lang guys, no? So ang nangyari dito, lahat ng X natin kasama si education pinasok pa rin. Okay, sa panel regression guys, ang gagawin niya, okay, fixed effect within time guys, tatanggalin niya yung mga variables na walang contribution dun sa pag-explain ng changes in time. Okay, and then you have now same thing here, factors, okay? Okay, so yung ito hindi significant yung sa factor 2. And again guys, this is interpreted in reference to time 1. Okay. So dito si weeks, hindi siya significant. Okay, and then we already explained how this is to be interpreted. This is 0.111. So it means that for every one increase in 1 year of experience, there's a corresponding. So this is actually 0.11 times 100. Okay, so that's 11.19% change in your wage ceteris paribus. Okay. So nakita natin guys na iba yung panel data regression fixed effect with OLS but using the same regressors. Sa panel data tinatanggal yung mga time invariant na variables. All right. Mamaya na natin titingnan guys kung ano ba mas maganda, no? Kasi we're just running the models, running the regressions, and then later on we'll see which among these is the model that we should be using. Okay. So as I mentioned guys a while ago, for fixed effect panel data within time, it's different from the OLS using time as a factor. Sabi nga natin, di ba, tinanggal dito sa fixed effect yung education kasi hindi naman nagbabago si fixed effect over time. All right. Now next, how about fixed effect within ID naman? So ang mangyayari dito, guys, hindi natin titingnan yung impact ni time, ang titingnan natin yung impact ni ID. Okay, yung individual units, yung 595 individual units na yan. Okay, dito ang mangyayari. Di ba remember guys, pag fixed effects, ano nangyayari? Pag fixed effects, okay, tinatanggal yung mga time invariant. Okay, take a look at this. Si ID ba time invariant? O 1, 1, 1, 1, 1. Over 7 years guys, hindi naman nagbabago si 1 eh. Okay, over 7 years, ito si 2 hindi nagbabago, right? So kahit na sabihin mong sige mag-fixed effects within the units, since the units do not change, mawawala lang yan. No? Note here, the factor ID is dropped also, just like the time invariant variable ED. Okay, ID likewise is invariant over time. For example, ID1 does not change from time 1 to time 7. ID1 pa rin siya. Okay, so let's regress this now. Okay, again, let's call it fixed effect with ID, PLM, log of wage regression, the 4 variables, plus isasama natin si factor ID. And then what's different with this compared to LM is that kailangan i-identify natin yung model. So kapag fixed effect, within yan. No? Within. So let's click this. Okay, ano nangyari guys? Take note na kahit na sinama natin si factor, no? As a regressor, okay, hindi siya pinasok dito. Unlike dun sa LM natin kanina, pag in-LM natin to, di ba? Nung in-LM natin to, okay, hindi nga lang natin sinama tong model na to kasi hindi naman siya panel data regression. Yung factor na to, magkakaroon ng dummy variables na 594. Dito sa panel regression, sa fixed effect, tinanggal siya. Okay? Kasi wala namang effect yung wala namang effect yung ID within the dun sa change ng years ng 1 to 7. hindi naman nagpapalit yung ID, hindi siya nag-change. So time invariant siya. Kaya what happened was tinanggal ng model na to lahat ng mga time invariant, including education, we know that already, and also yung ID, no? Since it's also time invariant. All right, so we have this. Itong model na to, fixed F with ID. Okay, this is another model. Okay, as I mentioned a while ago, mamaya na natin titingnan kung sino mas maganda among this. No? What we're doing now is just we're running the panel data regression. All right, next. Okay, we now have, ito naman, medyo, okay, between estimators. No? So fixed effect between estimators. Ano nangyayari dito? So it simplifies the regression and allows more focus on the independent variables. So ang gusto natin talaga makita dito yung effect ng mga independent variables, yung experience squared, yung weeks at saka yung education. Okay, sabi ko nga dito, it simplifies regression and allows more focus on the effect of the independent variables. Okay? Calculates averages of both x, y, and x over time, and then regresses y on x. Okay, anong kaibahan nito dun sa kaninang OLS na regress lang natin si y on x? Okay, di ba yung unang-una natin yon, di ba? That was our first model, yung OLS natin. This one. Ito. Panel regression. Sorry. Saan yun? Regression. Panel regression. Ito guys, ito. Sorry ha. Ito, OLS to, no? LM, linear model. So hindi natin dito tinitingnan yung effect ng ID at saka ng time. Dito naman guys, panel to, no? This is panel regression. So, ang mangyayari dito, iba to. Okay? What will happen is that, ang gagawin niya, yung log wage, okay, for individual one will be average. Tapos yun ang gagamitin niyang dependent variable. Tapos lahat ng mga x, nari, sa experience ng individual number 1, i-average na yun ang mangyayari na experience. So experience squared din, lahat ng experience squared ni individual 1, i-average yun. Okay? So parang nako-collapse siya. Nako-collapse yung yung model natin. Instead of using for individual 1, for example, instead of using 7 log wage, okay, why don't I write it down? Sige. Let's use this, guys. Okay. Remember sa OLS, let's say, yung log wage natin, L wage. Tapos ito yung ID. So, 1, 1, 1, 1, 4, 5, 6, 7. So we have value here, value, 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 value. Okay, sa OLS natin, lahat ito gagamitin, everything. All of this will be used. All used for OLS. Okay. Pag paano naman guys, ang mangyayari, i-collapse to. This will be collapsed. Magkakaroon ngayon ng i-average niya yung x na yan. Okay? So that for ID1, your L wage will just be 1. Kuha, guys? So also your experience will just be the average of the experience ni 1. Okay, so therefore for ID 2, 3, 4, yung mga averages na lang nila. So all in all guys, how many observations will we have? We will have 595 observations. Okay, as compared to OLS where you have 4,195 something. Yan, yun ang difference, no? So pag between estimator, ang gagawin guys, kasi ang tinitingnan natin pag between estimator, ano yung difference kung between 1 and 2 and 3 and 4? So what happens now is just we just get one value for a log wage for ID1, for ID2, for ID3, etc. Just one value for experience for ID1, ID2, ID3, etc. Okay? So that's what happens with between estimator. So let's go back to our model. So between estimator, okay, so this is our code. Y on X, data is equal to panel wage and then between. Okay, so let's run everything here. Okay, tingnan natin guys, ha? Alright, tingnan nyo guys yung N. Balanced panel to, okay? N is equal to 595. Kanina yung N natin guys, 4195. Ngayon, naging 595 na lang. Bakit guys? Kasi nga, kinuha yung averages na ng LN wage, for example, for ID1, ID2, etc. That's why na-collapse siya. You represented ID1 with just one value for LN wage, with just one value for experience, etc. Okay? So now what happens is that, okay, andito yung ano natin, yung regressors natin. Okay? Now, this will have a different value kaysa dun kanina sa OLS. Kasi sa OLS natin, 4,195 yung observations na yun. Ito 595 lang. No? Okay? So, it turns out that everything is significant here. And then yung effect ni experience here, okay, ang sinasabi nito, for every 1 year change in experience, 1 year increase in experience, there's a corresponding 3.8%. So you multiply it by 100, no? Kasi log lean model to, di ba? Pag log lean, okay, you interpret the independent variable as units, and then you interpret the dependent variable as percent. Kaso magmo-multiply tayo ng 100. So 0.038 times 100, that's 3.8. 3.8, tapos lalagyan natin ng percent. 3.8% increase in your wage, ceteris paribus. Okay, ceteris paribus. Okay, so that's your between. Okay, that's your between, fixed effects between estimators. Okay, next. How about this? Fixed effects then, pero with a lag. Okay, ano naman yung lag? Ang gagawin natin dito, Cx plus yung lag ng x. Okay, so what will happen here? Tingnan natin yung output, ha? So, i-regress natin si y using PLM again. So, ito within din to, no? Within. Pero isasama natin not only x but the log of x. And see what happens here. Okay. Ano nangyari, guys? So you have log of x, no? Na experience, log of x na experience squared, log of x ng weeks. Okay, why is that so, guys? Hindi ko nalagay yung ano, no? Hindi ko nalagay yung notes natin dito. Okay, anyway, explain ko na lang. Okay, log of x, bakit nawala si ano? Bakit nawala yung x? Okay, why did I remove it? Bakit nawala si ano? Si experience squared? No? Nawala sila. Bakit ang pumasok na lang yung log of x ni experience? First, ano ba ibig sabihin ng log of x? Okay, so let's take a look at this. So ito si experience, di ba? Pag sinabi nating log of x, ang mangyayari, log of experience, 4 will go up here. Okay, 5 will go up here. So yung second, guys, second observation, mapupunta dito sa first. Okay? So what will happen is that mawawala ng isa. Okay? Kasi for individual number 1, let me write that. Let's copy this. Copy ako na. Hirap makapit dito. Let's write them. So for example, ito si experience, no? So 3, 4, 5, 6, 7, 8. So experience na at t minus 1. Okay. So ang log niyan, pupunta siya dito 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay, so what will happen now? Itong row na to, okay, wala na kasi siyang kapartner na log, guys. Mawawala ito, ah. Okay. This will be removed. No? I hope you're getting it. Okay, so let's go back to our model. Okay, so going back to our model, so we were regressing your log wage on the log of x. Yung log ngayon, guys, yung nangyayari, ang gagamitin, itong ano, this one. Ito yung log ni x, lag, and then plus yung x, and then it's within. So when we run this, okay, what happened? Bakit 595 siya? Guys, bakit 595? Kasi, sorry, wala palang sasagot. Bakit 595, guys? Kasi, ang mangyayari niyan, guys, 595 kasi i-average din niya. No? I-average din niya yung mga variables na yon. Okay? So pag in-average na niya, okay, so you still have 595 as observations kasi each ID will now have their own values. No? Okay, guys? Okay, nag-pause lang muna ako dun. So, ang naging significant lang yung, okay, may sinabi dito, 3 drop variables because of singularities. Okay. Siguro, guys, ang gagawin ko ganito, no? Since hindi ko na-explain to dito, just to make sure, I'm going to explain the output here. Okay. I forgot to put it here. And then resend this file again. Okay, para nasa notes natin yung change na to. But just remember that this is also a fixed effects, no? Within to, so sabi natin pag within, ano nangyayari? Okay, may log tayo at saka may x tayo. We will still have 595 units kasi i-average na yung mga different values na. Okay, now this one, first differences, ang ginagawa naman ito, guys, ima-minus niya. Ima-minus niya yung value at time t versus time t minus 1. Okay, so for example, ito. Si education, guys. So this is at time t and time t minus 1 for individual 1. So pag minus yan, 9 minus 9, what happens? 0. 9 minus 9, 0. 9 minus 9, 0. So education will now become, ito, yung first difference na to, will become 0, 0, 0 lahat yan. Kasi hindi naman pwede maging regressor yan, 0, 0. Pati ito lahat, sa lahat ng mga individual units, guys, 0, 0, 0 lahat yan. So what happens now is that your education now will be dropped from the model. Ano pa? Ano pa madadrop sa model? How about experience, guys? So 3 minus 4, 1, 4 minus 5, 1, 5 minus 6, 1. So ito naman lahat 1. 30 minus 31, 1. Okay, so since lahat 1 to, guys, madadrop din yan kasi wala namang variation yan eh. 1 lahat eh, di ba? Alright, so this is all 1, yung first difference niya. Remember, pag first difference, mina-minus mo si time t sa time t and then time t minus 1. So mina-minus natin lahat yan. Okay? So 1, 1, 1 lahat yan. So everything here is 1. So ano pa yung predictive power niyan? Ganon din itong si education. 0 lahat naman lahat to. So dito sa sa first difference, madadrop to. Itong experience, itong education, guys. Madadrop yan. Civics hindi, no? Kasama pa rin yan kasi iba-iba naman yung values niya. And also si experience squared. So let's see what happens. First difference. Okay, so inexplain dito, inexplain ko, guys. Also experience increases by a constant 1, so the FD will be, first difference will be equal to 1. So pag minus mo na minus between two values, laging 1 yun. Okay, thus only experience squared and weak will be left as regressors. So that's model FD. Ayan, guys. So ito na lang yung naging regressors. Take note yung adjusted R squared niya, it's very, very small. 0.3% lang. When you compare this with the others, mas mataas yung adjusted R squared niya. Alright, so that's the first difference. Okay, last. Okay, yung panel 5 natin yung random na. Okay, so ang main method talaga is fixed pooled, no? Pooled OLS, okay, which means na baliwala na yung panel data natin. We ignore that. We ignore the heterogeneity of the units and the time. And then we have fixed effects, the different types of fixed effects. We looked at the different types of fixed effects, guys. And then lastly, so different types of fixed effects, for example, fixed effect within time, fixed effect within ID. Okay, then we have fixed effect between estimators. Then we also have fixed effect and a lag. Then we have also yung first differences natin. Okay, and then last one is your random effects estimator. So you have pooled OLS, you have fixed effect, and you have the random effects. Okay, may notes ako dito sa random effects dito, guys. Sabi, bakit tayo nagra-random model? Unlike fixed effects model. So here, we're assuming that the variation across entities, across units, is assumed to be random and uncorrelated. Okay, so dito ina-assume natin na yung differences sa mga units natin, random siya, and hindi siya uncorrelated siya with the predictor or independent variables. So what? Okay, if you have some reason to believe that the differences across entities have some influence on your dependent variable, then you should use random effects. Okay, so again, if you have reason to believe that the differences across entities have some influence on your dependent variable, then you should use random effects. Ang advantage ito, guys, is that you can include invariant variables. Okay, like in our case, ano yung invariant, palitan natin ito, education. Okay, education is invariant, so pwede natin magamit kapag random effects. In the fixed effect models, these variables are absorbed by the intercept. So, natatanggal siya. Okay. So, ito na guys. Let's now do the random model, PLM. And then model random. Let's run this. Okay, so what do we have here? Okay, so andito si X experience squared, X weeks, at saka si X head. Take note guys, si X head, kahit na time invariant yan, kasama siya dito sa random. Okay? So again, you have the interpretation. This is significant, X experience squared significant, then si weeks, hindi siya significant. Okay? So, dinala natin R squared. Adjusted R squared is 41.95%. Hindi natin natingnan yung previous. Pero ika-test naman natin yun kung sino mas maganda model, guys. Okay, then there's one thing here. Okay, may theta dito. Okay, anong ibig sabihin nito? Ang ibig sabihin lang ng theta, guys, okay, na-explain ng individual units, okay, yung variation ng ano natin, ng log wage natin, 82.28% comes from differences in the individual units. No? Ito na-explain ng individual units, in differences. All right. So, okay, lastly, guys, let's now determine which model to use. Okay. So first, let's compare si random effects versus OLS, pooled OLS. Let's compare this. Okay, we're going to use the PLM test. Okay, ang null hypothesis natin, the pooling method, pooling or pooled OLS is better than random effects. Between test natin, let's run this. Okay, so dito, p-value is practically 0. So we are rejecting the null hypothesis that pooling method is better. So ang answer natin dito, between random effects and pooled effects, mas maganda si random effects. So if we have the choice between the two, ang gagamitin natin sa random effects. So i-compare naman natin guys si fixed effect at saka si pooled, si OLS. Ang null hypothesis din ito, dito guys. Ang null hypothesis dito is that pooling method is better than fixed effects. Okay, so let's run this. So PF test, fixed versus pooling. Sorry. This is not fixed. Gamitin natin si fixed effect with time. No? Kasi marami tayong fixed effect. No? Fixed effect with time. Oops, wait. Sorry. Mali itong ano ba. Fixed F. Okay, fixed F with time. Right. So again, guys, our conclusion natin is that mas maganda yung fixed effects kaysa kay random effects, kay pooled OLS. And then last, guys, to decide between fixed effect or random effect, we use what we call the Hausman test. Dito sa Hausman test, ang null hypothesis natin is that random effects, si RE, is better than FE. Okay? Ang tinetest dito is whether the unique errors are correlated with the regressors. Ang sabi ng null hypothesis is hindi related si errors and the errors ng model are not correlated with the regressors. Okay, so Hausman test natin. Okay, so this one, RE method is better than fixed effect. So ito yung ano natin, yung Hausman test natin. pH test, random, and then fixed effect with time. Run natin to. Just this. Okay, so it turns out that fixed effect is better. P-value is less than 0.05. So we reject the null hypothesis that the random is better. Or meron tayong ano yung kanina yung fixed effect in within this, which is the same as fixed effect with ID. So let's test this also. pH test ng random versus fixed effect within or fixed effect with ID. Let's run this. Oops. Ano yung mali ko dito? Fixed effect within with time within. Tama po na. Fixed effect within. Ano ba yung tawag ng model natin kanina? Sorry. Fixed effect within, where is that? Random fixed effect. Fixed effect with time. Fixed effect with ID. And then fixed effect within. Okay, did we run this? Okay. Ang sinasabi dito guys na fixed effect with ID is the same as fixed effect within. Okay. I don't think we were able to run this a while ago. I'm going to copy this. Baka nagkamali din ako ng ano ng okay, here. Did I control V? Okay, it's the same. Okay, run natin to. Okay, so dito guys, okay, based on the Hausman test, it's saying that yung fixed effect within time, ibig sabihin, with time, ibig sabihin, time is included as a regressor. Compared sa random, mas maganda to. So dapat isama natin yung time effects. Ito naman, yung within, yung units guys, mas maganda si within. Okay, so in other words guys, gagamitin natin si fixed effect and not random effects. So which means that isasama natin yung effects ng time. All right. So now that we know that yung fixed effect is better, ang tanong na lang, sino mas maganda? Kasi marami tayong fixed effects, no? We have fixed effect with time versus fixed effect within. So sabi mo dito, which is the same as fixed effect with ID. Okay, so let's run this test. Okay, fixed effect within is better than fixed effect with time. Okay, so let's run this. All right, answer guys, p-value is less than 0.05, so we reject this null hypothesis. This is fixed effect within, ano lang yan, yung ang ginagamit natin dyan, yung ID, no? Yung difference, heterogeneity ng ID. Ito naman, yung heterogeneity ng time. In fact, tinanggal nga natin yung ID, di ba? Kasi sabi natin si ID does not change over time. So ito, yung sinasabi dito, gamitin nyo yung with time effects, fixed effect with time, kasi nagbabago-bago yung effect ng time. All right? So, okay. And then so our model, final model na is final model fixed effect with time. Okay? So, i-generate nyo yung output dito. I-generate natin dito. Fixed effect with time. Okay, fixed effect with time. Where's that? This one. Let me generate this. Okay, Okay, so ito yung ano natin guys. This is our final model, no? Only that yung iba hindi sila significant. So ang papasok na sa model natin itong experience squared, and then yung effect ng yung mga factors guys, kahit na hindi significant, pinapasok pa rin natin to, no? Yung dummies natin dito. Okay. Alright. So that's our final model. Okay. And lastly, ano na lang yung diagnostics, may test for serial correlation. So you have this test, PBG test, fixed effect with time, kasi ito na yung final model natin. So may serial correlation ba among the residuals? Okay. So ano to? Boyce-Godfrey test. No? So ang sabi dito, okay, P is less than 0.05. Ang null hypothesis natin, no serial correlation. So ang conclusion natin, we reject the null hypothesis. No? So there's correlation, serial correlation between the residuals. So how to address that, guys, is outside our scope. So we can just conclude that there is serial correlation in this panel data. Okay, next is test for heteroskedasticity. Linagay ko dito yung library na LM test kasi hindi ko siya nalagay sa taas. And then the residuals are homoskedastic ang null hypothesis. Bruce-Pagan test. Okay. All right. P value is less than 0. Okay. So we reject the null hypothesis, no? That the error terms are homoskedastic. So merong heteroskedasticity. Dito na lang guys, pakita ko na pag nagkaka-heteroskedasticity, ngayon madali na kasi pwede nating lagyan ng ng mga corrections, ng mga error corrections. So these are just some of them. Okay, i-outline ko lang dito guys na this is how you correct for for heteroskedastic residuals. There are different types of correction. Okay, so ito una, okay, coefficient test, variance, covariance, heteroskedasticity corrected na to. No? So there are different types, HCO, and then Arellano, HC3, etc. So iba-ibang types, no? Okay, we'll just run an example. Okay. So ito yung una, no? Itong una. How does it compare with the first one? 1.14, 4.16. Okay, pareho pa rin yung values, no? The values did not change. Ito pa rin yung model natin. Kaso nga lang, kinorek na to for the errors, no? Okay. This has been corrected for the errors. Tingnan niyo yung error dito. 2.16. Okay, 27. 7 p-value. Okay, I'm trying to compare them. Okay. So na-notice yung standard errors changed already, nagbago na siya. So by doing this, by correcting for the standard errors, na the model becomes okay na. No? So the model will not change pa rin yung estimates niya. Yun nga lang, na-correct na natin yung yung errors dito for heteroskedasticity. So you have another model here and another model here. Notice that the values will still be the same. Yung mga standard errors magbabago. Okay, and then this is another type, heteroskedasticity corrected third type. And then we can come up with this. Eh dito ilalagay lang niya sa isang, kasi may iba't ibang models guys. Heteroskedasticity corrected 0, 1, 2, 3, 4, models. And then this command will now, okay. So tingnan nyo to guys ha. Notice na magkakaiba yung ano yung okay, values ng okay. This measures your standard errors, no? Okay. X experience sa okay, let me run this again para makita natin. Okay, nawala naman yung isa. Anyway, guys sa HCO, ang standard error niya 0.00411, no? Nung rinan natin to, okay, 0.00411, ito yun. So plinat niya lang yung mga changes in your standard errors. So all of these now are HC corrected, no? Heteroscedasticity corrected. Okay, so we'll end in that, guys. Ito na yung panel data. Then I'll just post another video for yung time series. Okay, so thank you very much. If you have questions, please feel free to just email me.